This is our review on factoring. Let's get started. Now, theoretically, you guys know how to factor from Algebra 1. So the question I want you to be able to answer is, what is the difference between factoring and solving by factoring, or solving a quadratic by factoring? You'll also learn review on factoring, because I know it's been a while, but this is what I want you to be able to answer. All right, so numbers have factors, right? If you were to do a factorization tree, if you remember that, 2 times 3. 2 and 3 are factors of 6 because 2 times 3 equals 6, right? So 2 and 3 are factors of the number 6. Well, an expression also has factors. Okay, so x plus 4, this binomial, times x plus 1. These are factors. These are factors of this expression. X plus 4 times x plus 1 will give you x squared plus 5x plus 4. So factoring is a process of finding these factors. So what we're trying to do is find what will multiply together to get this expression. So when you're finding factors of 6, you're looking for numbers that multiply to 6. When you're finding factors of a quadratic, in this case, and for this unit, you're looking for what two factors will multiply back to get this quadratic or this expression. Now if you took these two and we multiplied them together, remember we said we would get this quadratic. So you would expand them or FOIL them, whichever you called it. Expand, which is foiling, if you remember the term foiling. Right, so x times x is x squared, x times 1 is 1x, plus 4 times x is 4x, which is how we get 5x. And then 4 times 1 is 4. So we hopefully remember how to do that. So what's happening now is we're just going back the other way, and that's factoring. So some people also say we're unfoiling. If you use that word, we are unexpanding. We are just going from a quadratic back to these factors. Now there are many ways to factor. And it doesn't bother me if you use one of the methods you've used before. The ones I'm aware of are the box method, grouping, drop and kick. There's other names for different ones. It doesn't matter to me if you want to use one of these methods, as long as you're factoring correctly and you understand what factoring is. The way that I teach you here is to think about what you're doing. Think about what two terms will multiply back to this, kind of like a guess and check. So if you have this quadratic x squared minus 2x minus 15, we know that you're going to have your two binomials. And remember from foiling, this term times this term has to give you x squared. So you don't have any other choices here but x and x. Now these two numbers, when you FOIL them out, they add or subtract up to this middle term, and they multiply to the end, because your L in the FOIL, your last term, is this times this equals 15. So you have to think of two numbers that multiply to 15. That should be a 15. But that also will add up to negative 2. So you've got 5 and 3, 15 and 1. In this case, it looks like 5 and 3 will work. So we also want them to add up to negative 2. So my signs need to be negative 5 and positive 3. And so if I were to check this, because it's kind of like guess and check, then when I FOIL it, x squared plus 3x minus 5x minus 15. And when I combine my like terms, I get x squared minus 2x minus 15, which is exactly what I'm looking for. So then I factored this correctly. Here's another example. I've got 2x squared minus 9x plus 10. I know I'm going to need my two binomials, put my parentheses, and that the first two terms have to multiply to 2x squared, because I'm going to FOIL to multiply this times this. So I don't have any other choice than 2x and x. And then these last two terms need to multiply to 10. So I've got a couple options there, 10 and 1 or 5 and 2. I'm going to try out 2 and 5, because 2x times x is 2x squared, and then 2x times 2 will give me 4x, and 5 times x will give me 5x. And I know that 4x and 5x, if I fix the signs right, I can get to negative 9x. And then negative 5 times negative 2 is positive 10. So again, just double checking it all out. That's 2x squared, and I just did these right here, but I'll do them again. Minus 4x minus 5x plus 10. And that gives me the quadratic I had started out with. So I factored it fine. Now there's a couple things I would ask myself before I factored, just to kind of make it a little easier for you. Is there a greatest common factor here? In this case, I can divide or factor out a 2 here. So it kind of just gives me an easier quadratic to work with. So if I factor out that 2, I get 2 times x squared plus 3x plus 2. So I divided every term by 2. I took a 2 out and moved it over to the side. It doesn't really go away, but I factored it out. And now I've got a much easier quadratic to factor. And then that's plus 2 and plus 1. Okay, so if you can take something out of each term, then I would do that to give you an easier quadratic to factor. The other thing I'd look at is if I was missing a b. Remember, standard form of a quadratic is ax squared plus bx plus c. So here's my ax squared, here's my c, there's no b. If you're missing a b, you have something called a difference of squares. It means that those two middle terms canceled each other out. So you can take this, it's kind of like taking the square root of the first, 4x squared, which is 2x, and that's going to be the same in both of your parentheses, and taking the square root of the 25, which is 5, and 1 plus, 1 minus. So if you can see that, then that's kind of a quick way to factor. If not, that's okay. You can still factor the other way, the guess and check, or any other method that you have. But if you check here, the reason we call it the difference of squares, and you can tell by missing a b, is if you were to go back and FOIL this, you get 4x squared minus 10x plus 10x minus 25. So these get canceled out because there's a minus and a plus. And you just end up with 4x squared minus 25. Now that last part was a review. Well, this is what I really want us to understand, which is solving the quadratic functions by factoring. So remember, if you're solving for something, you're looking for the solution. And we know the other words for solution are roots, zeros, or x-intercepts. So when we're solving a quadratic, we're looking for one of these. We're looking for the x-intercept. So what we've done so far is we've graphed a quadratic and we've found the roots, or the x-intercepts. So we've actually already solved a quadratic by graphing. Okay, there's 4 ways to solve a quadratic. Okay, one of them was graphing, which we've done because we just find the x-intercepts. And then this second way is by factoring. We'll learn the other 2 later. But solving a quadratic means finding the x-intercepts, finding the x's, solutions, roots, or zeros. So if you see in this quadratic, x squared minus 2x minus 15 equals 0, and it asks to solve. Okay, we're looking for the x's. We're trying to solve for these x's, which means we're trying to solve for the x-intercept, zeros, roots, solution. That's what it's talking about. So we could do that by graphing it the way we've learned it and find those x-intercepts. Or now, like I said, we can do it by factoring. And so the way you do that is just like it says, you want to factor. So if I factor this right here like we did in the last slide, and I get x minus 5x plus 3 equals 0. So from here, we still need to find the x's. And so that's what I'm going to show you on this next slide. So we have this property called the zero factor property, which is if a times b equals 0, then a equals 0 and or b equals 0. Well, that makes sense, right? 2 things multiplied together, if they equal 0, one of them, at least one of them, has to equal 0. So if we go back to the example we were just on, right, where x squared minus 2x minus 15 equals 0, and then we factored it, that's the first step when you're solving by factoring. is that we factored. The next thing, once we're here, now we have an a times a b equals 0. So now we apply the zero factor property, which means you set each factor equal to 0 and solve for x. So I've got x minus 5 equals 0 and x plus 3 equals 0. And now I just solve. So if I want to solve for x, I add 5 to each side, and x equals 5. Over here, I just subtract 3 from each side, and I get that x equals negative 3. Now I can go back and check and make sure when I plug in 5 here that this does equal 0. Same thing for the negative 3, and it will. So these are my solutions, these are my roots, my x-intercepts. If I were to graph this on a graph, then this quadratic would cross the x-axis at negative 3 and 5. And that's not a very good graph, but that's what it means. Okay, so you're solving a quadratic by factoring means you factor to get your two factors equal to 0, then you separate them, each factor equal to 0, and solve to get your x's. These are my roots, my x-intercepts, my solutions, my zeros. These are where they cross the x-axis. This is how to solve. Okay, so if you're still a little confused, go back and rewatch whatever part of the video you're still confused on, whether that's factoring or solving. Don't forget to answer your essential question in your summary. And just a quick little reminder, if you have 4x squared minus 1, they ask you to factor, then you're factoring. And that's it. That's all you do. This is factoring. If you are solving by factoring, so that means you have 4x squared minus 1 equals 0, so that means you're trying to find the x, then you still factor, but you have to apply that zero factor property, which is that you set each factor equal to 0 and you solve for x. So x would equal negative 1/2 here, and x would equal positive 1/2 here. So there's your difference between factoring and solving. All right, I know that was long. Thanks for watching, and see you soon.